Hi, my name is Jack Polk, and today I'm going to be giving a presentation on my research of an evaluation and classification of anonymous communication systems. I apologize for not being able to attend today, as I'm currently out of town in Gainesville for another competition, but I hope you enjoy, and I hope I'm able to cover any questions or concerns that you have relating to my project. So first, to go over some of the basics, I'd like to explain what anonymous communication system is. Now, an anonymous communication system is any kind of system on a computer network that is able to keep a user's internet traffic secure and anonymous. So if someone is listening in on you going to Google or Amazon or Facebook, this tool should be able to hide that you're doing that and they don't know what you're doing. Basically, it keeps you hidden, anonymous, secure. Network traffic can be explained as packets that go between a client and a server, so back and forth like a conversation. And it's divided into two primary categories. So the first is metadata, and then the second is data. The data can be thought of as a letter that goes inside of an envelope, and the envelope is the metadata. So it tells the computer, where am I going to send this data? Who's going to get it, and then where are they going to send it back to me? How long is it going to take to get there? What's the latency, like how long did it take to get there on an average. And then so it gives us this kind of information, which is a description of how the data is being handled. And then the third is machine learning, which is a branch of computer science that lets us take a lot of data and train our model off of it, and then we give it new data, and it's able to tell us, hey, that's this application, hey, that's this thing, and it classifies new data that it hasn't seen before based on what it has learned. And so anonymous communication tools can be used for a number of different things. So it can be used for bad in the sense that people often use this to hide malicious activity that's going on if they want to exfiltrate sensitive information from like a business or something. And then it's also used for good though, in the sense that if you went to China and you didn't want your information to be censored or monitored, you could use these tools or just in general, if you're just at a coffee shop in your house, it helps keep you anonymous and secure, which is good. Now, we have a list of these applications. They're divided into proxies and VPNs. These are the ones that I chose. And there's no practical difference between them. They both accomplish the same goal. There are some technical differences. But in this project, we're only going to be going over shadow socks, SSH, and OpenVPN. And then we also are going to look at normal traffic that has been altered by these tools as a control group. So what we did exactly in order to test these tools was we first evaluated them to see if they were effective as anonymous communication tools. To do this, we looked at how strong they are in encryption, how safe your data is, how flexible the protocol is if someone wanted to modify it, how good are they at circumventing censorship tools. If you went to China, would this work? How easy is it to configure and deploy these tools? What kinds of platforms can it be installed onto? So Windows, Mac, iPhone, Android. What's the age of the application? And then when was it last updated? Looking at packet features of just the metadata, we were looking specifically at the packet size, the average packet size that was going out of our client, the frequency, how fast the packets were going out of our client, the number of packets total that were sent in one instance, the packet entropy, so how random these packets were, that can tell us if there's encryption or not. 5 is the percent of packets that are coming in, 6 is the percent of packets that are going out. And then what we did for an implementation of such a structure is we had a client that would use one of these anonymous communication tools to go over a network to a server that would take its request and then say, oh, okay, I got your request, let me send it back to you. And this would go on for one instance, and they would talk back and forth with each other. And as this conversation was going on, we were listening in on that from the synthetic conversation and then storing that to a file of exactly what was happening at the time. And then so with this data, we parsed out the important stuff using a couple of tools. So the first was Joy, second was CapInfos. They basically took out these packet features I was talking about before and then stored it into one of these files. And so we would take these important features train our model, and then it would tell us based on traffic that it hadn't seen before. We selected part of the data to train it on, and then the other part was used for testing. We were able to figure out on the unseen data that it hadn't seen before what program it was using. And so to analyze this data, we first used the J48 and random forest algorithms. These are machine learning algorithms that are used for classification. And we can see the true positive. I'm going to explain first what the performance metrics mean on here. The true positive tells us how many instances were classified as one thing correctly. The false positive tells us how many things were classified as one thing incorrectly. The precision tells us how many things were classified as one thing to a ratio of how many things were classified as one thing both correctly and incorrectly. And then recall tells us how many things were classified correctly to a ratio of how many things were classified correctly and not classified correctly. So it wasn't classified as one thing, and it was right about that. So for J48 and random forest, we can see that our true positive, precision, and recall were all high, which is a good indicator, and our false positive is low. For J48, there was some variance, but then in random forest, there was no variance, and it was perfect for true positive, precision, and recall, and then our false positive was 0. Looking at the actual count of how many were correctly classified, we can see that 77 out of the 80 were correctly classified for J48, 3 were incorrectly. It's 20 for the three programs, and then 1 for the unaltered, so that's a total of 80. And then for random forest, all of them were correctly classified. So drawing from this, we can say that we made a comprehensive overview of each of the applications, and we figured out what they could do and if they were appropriate for testing, and then we used the metadata that we collected from that in order to, from our trials, in order to figure out if we could classify them based only on the metadata, which we were able to do, which is really interesting, I think, because not actually hearing a conversation, but then figuring out the topic of what's being said, you know, if you were to think of it like that, is pretty astonishing. So in the future, what I'd like to do is collect some real-world data of people actually using these tools, because we were using synthetic data, but collect some real-world data and see how that works out, and then also migrate this testing environment, because some of these tools are hosted outside of our lab, and so we couldn't use them with the environment that we had actually right now. I just want to thank everyone that's helped me up to this point. I want to apologize for not being able to answer any of your questions, but I hope that my presentation was comprehensive enough for you to understand most of the concepts, and I want to wish everyone else luck that's going to present. Thank you.